So is everyone seeing my screen? You should just be seeing my Jupyter page here. Cool, cool. And I'm just looking at a few of these comments to see what I'm addressing. Cool. So I'll just quickly get started with going over this homework, and then, as I mentioned, I want to spend a bit more time going through, sort of preview of assignment 3, because this is going to be the first library that's allowing us to build interactive data visualizations, and also just introducing some intro concepts for web development in general. So to get started with data shader and large big data in general. So the first question was meant to be more of a classical aggregate, sort of big data visualization problem, where you have a large data set, and you're looking for strategies to try to wrap your head around this large data set. If you have smaller data sets, a lot of times it's a lot easier to just simply plot, like a scatter plot of what you have. But with larger data sets, you need to think a bit more about what the structure of your data is. And most of the time, especially pre-data shader, the way to do this is, just aggregating your data and using strategies such as binning to create summaries of patterns within the data. So the first question was pretty much looking at this sort of question. We have definitely, not the largest data set, but a pretty big data set. We have every tax lot in New York City, and we're looking to try to draw some conclusions about these buildings. So the first question was, we're looking at older buildings, and the way this is worded in the question, where the city is particularly worried about buildings that were unusually tall when they were built. So, we're sort of looking at, over time, buildings are being built. Over time, buildings are also getting taller, and we're sort of looking at, when sort of the first, N-story buildings were built. So when did buildings first start to, get above certain heights? And you won't really be able to see it. I didn't get any. I don't want to go there yet. So yeah, I didn't really include any, sort of grand summaries about, sort of just looking at, on one axis, the height of buildings, one axis, time, and just sort of looking at how buildings are built over time. But looking at a summary like that, you end up with, seeing some pretty cool patterns. So, you're able to sort of see when various technologies are being invented. So for example, you're able to pretty clearly see when elevators were first invented. That really allows buildings to, given sort of the ability to build taller buildings, but just simply not the ability to, or the desire for people to walk up 20 or so flights of stairs. It's, you have, elevators really allow you to build these taller buildings. So Chun-Hui is asking a question about the number of floors. So you checked out an address. Okay, so there was a building that was showing 119 floors, and yeah, I mean, so the data set in general, it's, as I'm sure you guys sort of found out, as you're exploring it, it's not the cleanest data set. Although something like this, where there's an 119-story building where it shouldn't be is not really typical of this data set. The only and if you know the neighborhood Chunhui, you could sort of put that in the chat and we could try to see what building it is. My only thought is it's one of the newer buildings in downtown Brooklyn, like the Brooklyner or something like that. But aside from that, there's I do agree that that's um, One World Trade Center is 110. So yeah, that's got to be some data error that's happening there. So yeah, it's probably not the cleanest data set. Oh, that's right. Yeah, I see it right there. It's 3 floors. So yeah, something's going on with something's going on with that data point, and it's again not sort of the cleanest data around. So on that, first, one of the initial things that needed to be cleaned up was when you initially plot the data over years, and this is just using 1 year increments, you see some pretty weird behavior. It's this sort of these sorts of spikes. It's doesn't seem right. So, in terms of dealing with this, if you look a bit more closely at what's happening with this data, yeah, Peter, are you referring to the tall building or the aggregations here, the chart? Yeah. So what did what does everyone think was going on here? Does anyone have like what sorts of thoughts did people have? Yep. So Dan, that's pretty much what's going on. Dan wrote in the chat that it's in fives, and that's absolutely what's happening. Especially with this is sort of pre 70s buildings, so it's it's too well timed to be representative of booms and busts, and even so, the these booms, it's pretty substantial. If you think about just the number of lots that are being built in off years versus on years, you don't have this is a substantial order, well, not order of magnitude, but sort of 8 times as many buildings being built during these certain years than during other years. And you see it's 1925, 1920, and also comparing it to what's happening in more recent years, where it's smoother, and you also don't have spikes like this. There's definitely changes in trends of how many buildings are built. Definitely earlier on, as the city was expanding, more buildings were built in general, but definitely not to the degree that we're seeing in this graph. And yeah, Peter and Dan, you guys had it on you pretty much nailed it, where it's you're with older buildings, a lot of times you don't have the granular information that you had with newer buildings. So starting only around the 80s, that's when you get yearly more yearly permits, and being able to sort of build that. And Chunhui, yeah, that's definitely that definitely is a factor. So if you look at so the first thing I did, looking at sort of grouping things by 5 years, was the first thing I did was just group it by 5 years, so you get more of a trend of what's happening. And Chunhui, you're absolutely correct that it's New York City started out as obviously a smaller city and then began to grow, and you see that pattern. You sort of see that growth, and you see the fact that just no matter boom or bust, there's just not as much land to build on. And so, you see a boom around the, roaring 20s, and then things begin tapering off from there. And, this is just sort of the broad trend, the building trend. And I used, I didn't really have I didn't have a chance to go through your homeworks yet. So I don't know sort of how you guys ended up doing these sorts of aggregations. Pandas has a lot of built-in functions that allow you to easily, manipulate data. And like if pretty much there's more manual ways of doing things. So, I wrote here that you could down sample years while keeping them numeric, but Pandas has really good date time functions, and you're able to sort of just select that you want this by every 5 years and use that as the way that you're aggregating. So I just chose to use that, but there's no harm in sort of doing a more manual, aggregation with doing it numerically. So, so I'm doing that, by time period, and that's how I ended up just with my summary like this. And this is, yeah. We're dealing with that. One way of dealing with this sort of irregularity is sort of aggregating it like this. And another way that you wouldn't even have to really aggregate it that much, because of the way that you're looking at it, is by looking at what's called a cumulative graph. So here, rather than looking at just number of buildings built in certain time periods, we're sort of assuming we have 100% of buildings built at our current time, and what percentage sort of going back over time, what, like, sort of just percentage wise, when were these buildings filling in. And here you still see that it's stepwise, and that's showing these irregularities, but it's not as jarring as what we were seeing before. So using something like this, we're able to get an idea of when, for example, sort of when were 50% of the buildings built, around the 1930s. And this is also useful for the sort of question that we're asking here, where we're looking at buildings of various, various shape, various stories, and we're trying to, find out when were the first types of these buildings built. So what I ended up doing for this was just creating a holder variable for for my different divisions. So I'm looking at 0 stories, 0 to 10, 10 to 20, etc. And I'm just capping my data at 50. Wherever you guys chose to cap it, that I'm not super concerned with, but it makes sense to, once you get above around 50 stories, you're dealing with tall buildings. So there's not too much of a difference between in terms of these sorts of questions, a 80-story building versus a 90-story building. So at least when compared to the difference between a 20-story building versus a 30-story building. So we have these bins created, and then all I'm doing is looping through those bins and looking at these different index levels and just creating a trace for each of those. So similarly to what what we were mentioning last week or 2 weeks ago and earlier today, with Plotly, you don't really have the grammar of graphics. It's more, sort of based on adding traces, which, pros and cons to that. It makes it easier to do sort of make more custom graphs. But, for something like this, you have to just loop through the data and add it to your traces. So with this, we end up with a trace of scatters, and I'm actually using subplots. So here I'm just gonna stack these plots on top of each other. So I have just a few rows and one column, and a few rows and one column, and then I'm able to view it in this way where we're comparing them. So Dan asked, what does it mean to create a trace? A trace refers to, so just in Plotly lingo, a trace is just a, if you like this blue line is one trace, this orange line is another trace. So if you're making comparisons, like if you have a scatter plot, for example, and you have different layers, and each of those layers would be a trace, and that's just pretty much how Plotly deals with data. There's like the Plotly object, it's a dictionary, and the data portion of that dictionary is simply an array of these traces. And and usually you'll see this with on one set of axes where you have multiple lines and you're comparing them, or you have a scatter plot and you're looking at traces differentiated by color, and you're sort of viewing your graph that way. And so usually you'll see it like that. But in this case, because I just wanted to keep this 0 to 100% scale for each of the categories, you're able to see sort of more easily compare what's happening. So what we see here is we're just you're able to get like looking at things cumulatively. You could choose whatever cutoff you want and sort of use that as your guideline to get an idea of when sort of people got a hang of building buildings of certain heights. So looking at like 0 stories, that's just sort of building houses. But if you're looking at something like let's say we had a cutoff of 50%, where we wanted to be perhaps more conservative, we wanted to check the first half of buildings that were first built to be over 10 stories. Something like that, you reach that point in 10-story buildings around the 1930s, so sort of January 1931. With 20-story buildings, you don't reach that point until the 1960s. And similarly, you get different dates, like you reach it around the 1980s for 30-story buildings, and similarly for 40 and 50-story buildings. And you could map all of these to technological improvements, as you're sort of having elevators, as you have steel frame construction to allow you to get even higher than just with bricks. And you could sometimes see in these graphs, when the slope increases, that means that there's a flurry of buildings of those heights. So you could kind of see inflection points of when like you have some buildings that are built that are 30 stories, perhaps those are using outdated techniques, and then you begin just really getting the hang of it and building more buildings like that. So using something like this, to answer the question as posed, you would look at these different categories, pick whatever cutoff you want, map that cutoff to a date, and use that as your target for checking buildings. So the sorts of buildings you would inspect would be any buildings built earlier than those dates that you chose. So any questions on that first question, or did anyone else have any other interpretations of the question? Cool. So the next question, this was more of a straightforward question. and was really meant to, and actually Vikas had a question about the first questions. Is the use of subplots an example of small multiples? Absolutely. This is an example of small multiples. So that's a good catch there. That when you are looking at this, you're sort of making the comparison with several different like in ggplot lingo, this would be more closely related to facet style plot. So yeah, absolutely, it's small multiples. Cool. So for data shader, the question was a bit more straightforward, and I designed it that way because it's sort of as people mentioned in the beginning, it's a bit rough around the edges, and it's something that I really wanted to just expose everyone to, and kind of just think about. Data Shader does, like, it is kind of niche if you think about it, but for this sort of exploratory work, it really is a cool package. And just in terms of the what it's doing algorithmically, it's pretty innovative. There's like really like something like this hasn't been attempted before. So it's a pretty cutting edge library. So the question here was, we're looking at the same data set, and this time we're pretending to be a real estate developer, and we're researching what could be perceived as underbuilt areas of the city. So what we see in the Pluto data dictionary is we have two parts of the of of the value of the land. We have the assessed structure, or assessed land, and assessed total. And I apologize, I actually miswrote this. Did anyone get confused with trying to calculate assessed structure? And if anyone we're just comparing assessed total to assessed land, that's totally fine for these purposes. But I just want to make sure that no one was super confused by that. So in the comments, like, put if you were. But so what I ended up doing here was the two values that we have is yeah. So yeah, Dan, I'm gonna we'll put a pin in that, because I'm gonna talk about some of the pros and cons of using this of using the sort of bivariate choropleth maps here. And so using a ratio, it's definitely definitely valid in this use case. So looking at this, we have assessed total and we have assessed land. And what I did was, I sort of mapped it out to one of the color scales that we have here. So scrolling down to the bottom, this author provided us with some good to use color scales. So I just picked one of these and used it. And what this allows us to do also is to sort of use data shader in the it's not technically what we're measuring, and there are definitely pitfalls to using this sort of method. And but what we're sort of doing is we're treating the scale as if it were a categorical scale. So as far as data shader is concerned, it has, and you can see what I'm doing here. I'm just taking percentiles to get my various categories. I'm using this apply syntax here. So this is, and this lambda syntax, which is basically just a way to apply a more complex function to a column to get another column. So this is similar to, in R, the plier language, the plier library. where you're able to define functions, the whole split, apply, combine technique. Like this is pretty similar to what we're doing there. I'm just using these Lambda functions to do that. And at the end of doing all that, I end up with a categorical, and I'm defining it in this case as pandas categorical because pandas, just like with time series, it has some pretty useful ways of dealing with categorical variables. And I'm, just simply sort of defining things categorically. So I have my color key. I'm sort of using that to map out, to sort of map colors to the various categories here. And then once I do all of this prep, my example ends up looking very similar to the racial map that in the examples that Datashader provides. So we have a sort of category that we're looking at. In this case, we're looking at this assess all 3 tile, and we're mapping that to a color key. So we have this dictionary that is telling us for each of the categories we're applying a certain color. And yeah, Brian mentioned, is there a rule or in the chat, if there's a rule or guideline for how the bins should be created? I ended up, so yeah, Brian, in the chat, if you could, sort of explain how, which sort of method you chose. Like you mentioned, it's arbitrary, but if you, had,
Sure, I can,
yeah,
can you hear me?
yeah, I can.
Sure. So I noticed that some of the values were very heavily skewed. So I didn't necessarily feel right about just splitting them percentage wise, because the top group would be an incredibly large range of values, some just merely a little bit large and some extremely large. So
Mm-hmm.
I ended up just kind of playing around and picking different demarcation lines for each of the 2 values and just kind of checking the resulting size of each of the bins, and then just kind of so almost arbitrarily settling on something that more or less had elements in each of the 9 bins, but at the same time still somewhat felt representative of the size of
Mm-hmm.
the elements. It was arbitrary. So I wasn't really
Mm-hmm.
sure
Mm-hmm.
if there was a better way to go about it.
No, so I mean, there's no one right way to do something like that, and definitely I mean, you're calling it arbitrary, but you're putting thought into what these bins are. So if anything, that's sort of more well thought out than even what I was doing here. What I'm doing is just simply using percentiles. So in my case, I'm assuring that the bins are going to be of equal size, but you're right that it would have helped to do a sanity check on the data and see if there's any bins that might make more sense. I'm definitely a fan of not just following a blind algorithm in terms of things like this, but trying to get a feel of what you want to show. So, for example, if I were like if there were like different classes of buildings, like if I noticed that there were a bimodal or trimodal sort of distribution, I would sort of key into that and maybe get an idea of, you have single family homes, you have pre-war apartment buildings, you have new sort of more newer construction, and sort of use that as guidelines. So absolutely, that's always a good idea to give more thought to what you're doing. But in my case, I
Great,
was
thank you.
yeah, yeah. So yeah, in my case, I was just doing the percentile. So we're assured that we're getting sort of even bins, but there are other ways to bin that. And and then what we end up with a pretty cool visualization here. So look, and again, like I mentioned, Datashader is not good at labeling, sort of providing color scales or anything like that. So it's, like I just provided sort of a little cheat comment. So you're able to, see what's happening there. I was previously using total for that, but I ended up changing that. And, so looking at something like this, you're able to get an idea of, sort of where areas might perhaps be over or underbuilt. So the cool thing about, and actually, this is going to touch a bit on who was it who mentioned the ratio? Yeah, so Dan mentioned, yeah, Dan, you mentioned that you were using ratios, and that's definitely a valid way of viewing this. The bivariate using this strategy, like using a bivariate color scale, you get slightly more information. So, for example, you're able to differentiate between areas like Midtown Manhattan, or most of Manhattan below 96th Street, where you have sort of a maroon color, which means that you have high land values as well as high structure values, versus areas like the Northeast Bronx, Southeast, sort of South Queens, sort of Central Brooklyn and Staten Island, where you have both low land values and low structure values. So yeah, and Dan, you with using a ratio, you're not going to end up with a bivariate. Like you're going to end up with sort of fewer colors. Although, and actually, this is so this is more of just something to watch out for. But with something like that, so what sort of color scale did you end up using, first of all, for there?
In the end, I basically marked both ends so that it would create its own scale in between those. It actually
Okay.
took me a very long time to turn it from categorical into continuous. That was a big problem. But once I got that, I marked both ends and let it create the middles.
Okay. I'll have to see what you did, because I thought the last time I was using Datashader, it didn't allow me to map a continuous variable to, like you still were binning it, right?
No, I had
Okay.
actually the opposite problem. I couldn't get it to accept any sort of binned or categorical, but with the color scheme,
Hmm.
color mapping, it only accepted some sort of continuous type. So I had to go through a lot of changes just to move them into integers from categories.
Okay. And were you able to define that you were looking at this ratio, like you were mapping the continuous variable to this ratio?
Yeah.
Okay.
And
That might,
I could tell like parts of Manhattan where they should have been built up.
mhm.
And then I went through and picked, sampling of some buildings to see like what kind of like buildings were where in the city.
Yeah. Okay, that's interesting. I'll have to check that out, because I remember the last time, like I just added this last semester, and when I was first, sort of wrapping my own head around data shader, I didn't see that option of using of sort of mapping a continuous variable. And what I thought was happening was data shader is using a continuous variable to display the density of the points. So if we're looking at this, for example, we have we simply have, just latitudes and longitudes mapped out. So if you look here, I'm not mapping, I don't have any variables I'm mapping it to. I'm just simply, doing a scatter plot. And but I'm still sort of providing this CMAP here. And what it's doing is it's, sort of what it's mapping to that color scale is point density. Excuse me. So you're able to see, where where there's fewer buildings. You're able to see when there's really like fewer buildings, you're able to see individual points. You could see sort of towards, Hudson Yards, there's less, sort of a fewer number of large buildings. So you're seeing things like that. But it's, and I thought it was by design, although, yeah, Dan, I'll have to check your homework to see if they changed that, because, and this is sort of getting into the caveat with using a strategy like this, which is when you're putting points like this into Datashader, Datashader is doing multiple things. It's, sort of mapping out these points. It's making sure that you don't have overlaps depending on the order that you're putting layers. So if you look at sort of, this region of the South Bronx, for example, where you have a variety of, the building, these buildings have sort of a different variety. You have some areas where the structures are overvalued, some where, the land is overvalued. So it's pretty, you could get in trouble with regions like this if you just simply were using something like Plotly or Matplotlib, because, it puts colors on top of each other, and you'd get a different visualization if you plotted, one layer first versus if you plotted the other layer. And that's, definitely something that you want to avoid in visualization. But yeah, and Dan's mentioning, it seemed like a black box. It's 2 ratio categories. Yeah, Dan, I'm gonna have to check to see what you did, because it's, yeah, it's definitely like, it is kind of, rough around the edges in that way. But so yeah, getting back, I'm sorry, getting back to the scale here. So Datashader is really meant to deal with like truly categorical data. So if you're looking at the racial map as an example, that's truly categorical. You have the American Community Survey. You have each point representing someone who filled out that survey. You have people of different races, and you're just simply looking at that distribution. And if you're so for something like that, you're able to pretty neatly combine the sort of continuous variable of density with the discrete, the categorical variable of race. And for something like this, one of the pitfalls is we're actually looking at, and I forget which section it was. I think it was your section, but in one of the Ask the Instructor questions, I was talking about how dealing with multiple continuous scales, you could get yourself in trouble. I'm just realizing what time it is, so I think I want to try to move on from here. So if anyone has questions, put it in the chat, and I'll try to address it later. But I really want to get into some this intro to Shiny here. So let me. Where do I want to go? Oh, shoot. So apologies, I just need to clone what I have here. There we are. So I added these to our course repo just earlier today. So so they're pretty new. You probably didn't see them. And now I'll go here. So what I added were just some, there we are. I added some sample apps for Shiny, and I just wanted to go through a few of these. So, and since I'm here, let me bring up the assignment itself. So for assignment 3, we're looking at mortality rates across different states. So we have the data here, and we have a few questions that we're asking here. So someone, I forget who asked in the beginning. So Peter asked if I could clarify question 1. So for question 1, we're just really comparing mortality rates. Let's see. So we're looking at just a particular date, and yeah. So it's for each cause of death. Oh, okay. So Peter, yeah, we're not looking at just for question 1. We're not looking at just one cause of death. We're looking at all of, we're going to be comparing all of them. And I think it's, let me see if I just worded it incorrectly. So when I say like from, when I say from one cause, I mean like one cause at a time. So perhaps I should have clarified that. But basically, we're just looking at different causes and comparing those each across states. So yeah, sorry for the confusion there. And so yeah, we're looking at this data. We have the first question where we're comparing different mortality rates for these different diseases. And then for question 2, we're looking at how states are improving their mortality rates. Is it happening faster than or slower than the national average? Brian, for question 1, Brian asked if the data should be restricted to 2010. So for question 1, we're restricting it for 2010 for the whole app, but we're sort of comparing different types of mortality rates of different diseases. So for question 1, we're restricting everything by 2010. For question 2, we're looking at things over time. So we're adding in that extra time variable. Cool. So, so that's the data that we're using. And then the tool that we're using is going to be Shiny. So has anyone had any experience using Shiny yet? Cool. Yes and no. So we have a lot of, so we have some variation. Some people have, a lot of people haven't. So Shiny is Shiny is basically a way of building interactive visualizations entirely using R. So, and really what you're doing is you're building web apps. So, and actually, yeah, Dan, Dan mentioned ggiraffe, which actually I don't have that much experience with, but I believe, and I saw that in your last homework, that's more familiar, or that's more similar to, like, does it have, like I thought that was almost more similar to like Plotly or ggviz, where it's, interactive visualizations, but not so much the, building an app And with Shiny, what you're doing is you're really building an app. You're defining, you're defining a layout of your page. You're defining what your, what sort of, what your app logic is going to be, and you're sort of building all of this using R. So, I think the best way to kind of, start to get a handle on this is to just look at a few examples. But one thing to note, and I'll post a link to this in the content page. This is the, sort of getting started with Shiny, like going through each of the basic parts. And RStudio has some pretty good documentation on how to get up to speed with Shiny. But to get started, I'm just using some sample data here. And what we're actually looking at is related to what we were doing before. We're looking at housing prices here. And so this is a pretty straightforward app. I have, and I'll actually read, let me bring this in. So starting out, we'll look at the data. And I need to close my app. So let's take a look at the data that we're looking at. We have, it's a time series, so we're looking at this over time. And we have, as Hedley Wickham would call, a tidy data set. So we have our, we have different divisions of our data. We have seasonality, whether it's seasonally adjusted or not seasonally adjusted. We have metro, and then we have the tier of housing, whether it's high, low, or medium, or middle. So you could see all of that happening here. And then we have these housing price indices. And so running the app again, this is a pretty straightforward type of app that you would want to build when looking at this sort of data. So these are time series, so it's a good idea to sort of plot these out as line graphs over time. What I'm doing here is just simply on that same graph, comparing the high, low, and middle tiers, so you're able to see, are there any differences in those variables. And on the left-hand side here, what I'm doing is allowing users to make selections based on the other variables. So you're able to see whether you want seasonally adjusted data or not seasonally adjusted data, as well as picking different metro areas. So we could compare what's happening in these different metro areas, and get sort of clear ideas of this is pretty focused around the housing boom and bust. So seeing what different cities were experiencing in these times. So that's the app, and then to look at how it's running here, each Shiny app has two main parts. There's this UI, and there's what's called a server. And then they're put together in this last function down here. So you're running this Shiny app function, defining the UI and the server. And what the UI is defined with these, these are sort of Shiny specific. It's pretty useful for the sorts of apps that data scientists would be building using Shiny. You have things like header panels, side panels, main panels, and it's a pretty intuitive way of building these sorts of layouts. So here I have sort of a title, I have my sidebar where I had my drop downs, and then I have my main panel. And you could see that within the app here, I have my sidebar, I have my header, I have my main panel. And then within each of these elements, I have various, sort of sub-elements. I have elements within them. So in here, for example, I have, 3 what are called select inputs. Select inputs are just simply these drop downs. I have on my main panel, I have a plot output and a verbatim text output. And that's these 2 elements here. So my plot is just, in this case, a ggplot, and the verbatim text output is pretty much what you would see in your console when running it. So I have that as my UI, and then I have this separate object here called server. And server is where the magic is happening. So this is where I'm able to define what happens when a dropdown is being triggered. So and don't worry about this session. You don't even need to include it. So I could save it and rerun it. I don't know why I kept that there, but you have your server is a function of your inputs and your outputs. And you're referencing these inputs and outputs, the same way that you reference anything using R, but in particular, you're referencing it using these sorts of tags. So in a lot of these widgets, the first argument is going to be the tag, the ID, how you're going to reference that in later, sort of in the server of your app. So I have my plot output, I'm calling it plot1. I have my verbatim text output, I'm calling that stats, etc. And then similarly, I have my tags for my select input. And I'm going to be referencing all of these and tying them together in the server object. And so for Shiny, it gives us a lot of these pre-made widgets. So things like drop-downs, range sliders, all of these different, things that you would want to use to interact with a visualization. And it gives us these like output containers. So you have plot output. For Plotly, there's actually, Plotly specific tools to interact with Shiny. And plot output is basically saying, here's a plot. It's going to be, affected by what's going on in the server object. And you see 2 functions here. So each of these outputs, like this plot output, it's tied to what's called a render plot. And similarly with Plotly output, there's render Plotly. With verbatim text output, there's this render print. So there's sort of a one-to-one comparison with each of those. And these render functions are just blocks of code that end in either a ggplot and in some sort of command that's going to give me a print. And that's what's going to display in the plot output. So then let's look inside these. So using the plot as an example, I have, I'm first sort of slicing my data frame, and I'm accessing the input I'm sort of tying these variables to the input. So this input seed is being tied to this select input, tag right here, and same for Metro. So I'm tying these, I'm filtering this based on what is being selected in the input, and either returning a ggplot, or in this case, just printing out the summary of this. And that's all that's happening in this app. And when I run it again, hopefully it'll make slightly more sense what's happening here. So, making sort of selections with various metro areas and slicing data frames. So, so type your questions in the chat. I want to try to get through everything. There's some more content I want to go through. So so there's also another example I included here, which is called ggplot reactive. And ggplot reactive, if I run this app, it's going to look exactly the same. And it's, for a simpler app, you don't really need something like this, but it's good to know for as you're building more complex apps. Like, it really helps organize yourself, and it helps make apps more efficient. So the app, like, the logic is, it seems on the surface to be very similar to what we had before, but I have an extra step that I'm defining here. So I still have these, output plot one and output stats, but I have this new function here, which is called selected data. And selected data is defining, what's called a reactive function. So what I'm doing here is I'm saying, this function, I want to take in, seasonally adjusted and metro, and I want to filter the data frame in that certain way. And so this is, you could think of as sort of a block, like a chunk of app logic. And I'm referencing this chunk of logic later on in the app. So here I'm using selected data because, and actually I didn't really get a chance to note this yet, but when I'm making selections of seasonality and metro area, I'm affecting both the graph and the print. But when I'm choosing housing tier here, I'm only affecting the print down here. I'm not affecting the graph. And this adds sort of an additional layer of complexity to this app that, it's still fairly simple, but, this is sort of the beginnings of when you'll want to begin keeping more track of your app logic. So here you could see a kind of architecture of what we're doing, in the first app without the reactive code block. So all we're doing is the inputs are tied directly to their outputs. So I have a graph output, I have an info box output, I have 3 inputs. You could see housing tier, it's only affecting this info box, whereas seasonality and metro area are affecting both the graph and info box. And we saw that when looking at the behavior here. So the alternative is using a reactive code block. And a reactive code block is adding this additional step here. So what I'm, and this, it's good for, organizational purposes and efficiency. So here I'm saying, like, this reactive code block is referring, is sort of referring to seasonality and metro area. This is feeding into the graph and the info box. And then housing tier is a bit more cloistered off and is only affecting the info box. And for the app that we have here, these two architectures don't really make that big a difference in terms of the sort of, app that you're building. But one, key, one key place that this really comes into play is if you have, different functions that are of varying, costs. So let's say you have a dropdown that's leading to an expensive SQL query. You have another dropdown that's leading to, sort of a more trivial operation. And the way that, R is designed, you may be running that expensive query even if you're only making sort of the simpler calls. And what this is doing is it's you could use this as a strategy to cloister off more expensive calls. So this is something that maybe if you choose to use Shiny for your final projects, you might run into, but it's really it comes into play as you're building more complex web apps and you want to keep, first of all, just keep more track of your app flow, and also, sort of save those more expensive calls for really when they're needed. And again, I'm just going to sort of go through all of this, but put any questions in the chat and I'll adjust them as they're coming. So hopefully I'll try to get through this as quickly as possible. But I wanted to go through just a few general web development terms, because as we start Shiny, we're really building web apps, and it's with Shiny, and next module we'll be getting into Dash, which is a Python, it's like a more Pythonic, Plotly based, but still similar in structure to Shiny. You don't have to think too much about client side versus server side, but it does help to realize what's going on. So looking at this app again, we have in our server object here, we have these R functions. In this case, we're pretty much just filtering a data frame, but you could do whatever R is able to do there. You could, you could tie these to models. Like if you wanted to draw a best fit line, you could run a linear regression with each manipulation of the app. And you're doing that using R. So behind the scenes, what's happening is you have what's called a server side and a client side. So Shiny is a way of packaging all of this together so you don't have to think of it. And you have your so you have your client side. So that's everything that you're seeing here. So it's whatever is telling this graph to render. And then you have your server side. So that's what's happening when I make a call here. It's going back to the server. It's saying, okay, this user chose Minneapolis. Filter this data frame by Minneapolis, return the data, return the graph, and display it on the page. But as like you sort of get an idea of that with this server and UI concept. But this is really what's going on behind the scenes. And so really like the things to associate, like client side, that's what's happening in the browser. That's JavaScript. JavaScript is the language of client side web. And the server side is everything else. So that's what's happening on the server. So your databases, things like APIs, like if you make an API call to something, that's happening on what's considered the server side. And for our purposes, you don't have to really know the distinction for Shiny and Dash, but it makes, it's good practice to know. And for D3, when we do begin getting into that, D3 is a JavaScript library. So it can be integrated into more complex apps, and you could be making, client server, like you could really fine tune what you want your client and server side to be. But, but D3 is mostly happening on the client side. So for most of the apps that you're building, you're going to have bring in a CSV and sort of display your data there. And I don't think I have time to go through my hand-wavy thought experiment, but I do want to save this for next week. So for 2 weeks. Since we are still going to be in this realm, it'll still be relevant, even though we're referencing Datashader. But just to sort of give you guys a quick preview, this is just meant to really, at a very high level, sort of, go through a thought experiment of, what kinds of things you think of if you were building a web app from scratch. Warning, this is very hand wavy. I haven't actually tried this, so there's but hopefully this is a preview of what's to come in future meetups. So we'll have people from the second section coming in. So any questions before we head out? Yep, Chen Hui, I owe you guys both lecture 2 and this lecture. And unfortunately, I've been traveling over the past week, and I have to, I have to splice the 2 lectures and upload them, and I haven't had a chance to do that. I'll be traveling through the weekend, so I'm hoping to get that by early next week. But I will get these uploaded for you and for everyone. Cool. So unless anyone has any more questions, I'm sorry I sort of had to really breeze through everything at the end, but thank you everyone for attending, and we'll catch up 2 weeks from now, and good luck with assignment 3. All right, and if everyone could, or everyone who's with the previous, with section 1, if everyone could get off so so we don't run out of space. Although this isn't like my my Plotly GoToMeeting where the limit was 11 rather than 26, so we should have enough. And for anyone who's coming from section 2, welcome. And I'm going to pause the sharing for a second. I'm just going to put out the announcement for section 2.